From glowing clouds of gas to swirling disks of cosmic dust, our galaxy is filled with stellar nurseries. These incredible regions are where new stars take their first breath of light, shaping the future of our cosmic neighborhood. Let's zoom in on the Orion Nebula, our closest major star factory, sitting just 1,244 light-years away in the sword of the Orion constellation. This massive cloud of gas and dust stretches about 24 light-years across and hosts thousands of young stars. At its heart, 4 super-bright stars called the trapezium light up the nebula like a cosmic flashlight. These stars are babies by cosmic standards, only about 300,000 years old. The nebula's pink and purple glow comes from hydrogen gas being heated by these young stars. Think of it as nature's biggest light show, where we can watch new solar systems being born right before our eyes. The Hubble Space Telescope has shown us hundreds of protoplanetary disks here. These are the building blocks of future planets, making the Orion Nebula a true cosmic nursery. Let's explore molecular clouds, the dark, cold places where stars begin their journey. These massive clouds are mostly hydrogen and helium, mixed with tiny bits of space dust, and they're incredibly cold, around -440 degrees Fahrenheit. When parts of these clouds get pushed together by things like exploding stars or galaxy movements, they start to clump up. As more gas and dust pile on, gravity takes over, pulling everything tighter and tighter. The center of these clumps gets squeezed so hard that it heats up, like when you squeeze a stress ball and feel it get warm. This process can take millions of years, but eventually the middle gets hot enough to spark nuclear fusion, and boom, a new star is born. These stellar nurseries are so big that one cloud can create thousands of stars, each with its own possible family of planets. Now, let's look at how stars actually form from all this cosmic material. As gravity pulls the gas and dust together, something amazing happens. It starts to spin, like water going down a drain. This spinning creates what we call an accretion disk, a flat circle of material that looks like a giant space frisbee. The middle of this disk gets super hot and dense, forming what we call a protostar. Meanwhile, the outer parts of the disk keep feeding more material to the center, like a cosmic conveyor belt. The protostar gets bigger and hotter as it eats up this material. When the center reaches about 2,000 degrees Fahrenheit, it starts glowing red. But that's just the beginning. It keeps heating up until it hits a whopping 18 million degrees. At this point, nuclear fusion kicks in, and our baby star officially joins the stellar family. The Eagle Nebula's pillars of creation are some of the most stunning structures in our galaxy, stretching over 4 light-years high. These massive columns of gas and dust became famous when Hubble captured them in 1995, showing us what star formation looks like up close. Inside these towering pillars, dense pockets of hydrogen gas are being squeezed by pressure and radiation from nearby bright stars. The pillars get their unique shape because the outer layers are slowly being blown away by starlight while the denser inner regions stay protected. It's like watching a cosmic sculpture being carved in real time. Each dark spot in the pillars is actually a cocoon where baby stars are forming. The whole scene is lit up by young, bright stars nearby that make the gas glow in beautiful colors. When baby stars are forming, they don't just sit quietly. They throw spectacular tantrums in the form of protostellar jets. These powerful beams of gas shoot out from the poles of forming stars at incredible speeds, sometimes reaching 1,000,000 miles per hour. Imagine squeezing a tube of toothpaste too hard. The material has to go somewhere. As the star pulls in gas and dust from its surrounding disk, some of this material gets launched into space along magnetic field lines. These jets can stretch for several light years, pushing through space like cosmic lightsabers. They help the forming star by carrying away extra energy and angular momentum, which actually helps the star continue growing. The jets also crash into nearby gas clouds, creating beautiful glowing shockwaves that look like tiny bow ties in space. When we look at how stars form, magnetic fields play a huge role. They're like invisible hands shaping the whole process. These magnetic fields spread throughout the gas clouds like a giant spider web, helping to control how the cloud collapses. Think of it like a net catching cosmic material. As the gas cloud spins faster, these magnetic fields act like cosmic brake pads, slowing things down just enough so stars can form properly. They also create paths for material to flow along, like invisible highways in space. Without these magnetic fields, star formation would be way too chaotic. They help keep everything organized, making sure the baby star gets just the right amount of material at the right time. The fields even help create those amazing jets we see shooting from young stars, acting like cosmic launch ramps. Here's something cool about stars. They often come in pairs or groups. In fact, more than half of all stars have at least one stellar companion. When clouds of gas collapse, they sometimes split into multiple parts, each forming its own star. These stellar siblings stay connected by gravity, dancing around each other in cosmic orbits. Some famous examples include Alpha Centauri, our closest neighboring star system, which has 3 stars. These multiple star systems start forming together in their cloud nursery, sharing the same birth material. They can be as close as our Sun and Earth, or spread apart as far as Pluto's orbit. Their gravitational dance affects how planets form around them, creating some wild possibilities for alien worlds with multiple suns in their sky. Let's journey to one of the most spectacular star-forming regions in our galaxy, the Carina Nebula. Located about 7,500 light-years away, this cosmic wonderland is much bigger and more energetic than the Orion Nebula. It's home to some of the biggest and brightest stars we know, including Eta Carinae, a star so massive it's 100 times heavier than our Sun. The nebula spans an incredible 300 light-years across, filled with towering pillars of gas that dwarf the pillars of creation. Through our telescopes, we can see dozens of massive stars being born here, each one heating up the surrounding gas to create beautiful red and blue glows. The intense radiation from these giant stars is actually destroying the very cloud that created them, like a cosmic light show that slowly fades away. The James Webb Space Telescope has completely changed how we see stars being born. Its powerful infrared eyes can peer through the dusty clouds that hide baby stars, showing us details we've never seen before. Looking at the Orion Nebula, Webb revealed hundreds of never-before-seen young stars and even caught glimpses of baby planets still forming in their dusty cradles. The telescope's super-sharp vision lets us see features as small as a penny from 40 miles away. It spotted floating water vapor around forming stars, helping us understand how water, and possibly life, spreads through space. Webb's images show us star formation with such amazing clarity that it's like switching from watching an old TV to a 4K screen. Scientists are discovering new stellar nurseries and watching stars grow up in real time, completely changing our understanding of how these cosmic babies are born. Looking ahead, our galaxy's star-forming future is fascinating. While the Milky Way still has plenty of gas for making new stars, the process is slowing down. Our galaxy makes about 1 new star every year, but billions of years ago it was making them 10 times faster. The good news? We still have about 5 billion years of good star-forming conditions ahead. Places like the Carina Nebula will keep producing new stars, though some famous nurseries like the Orion Nebula will eventually fade away. When the Andromeda Galaxy collides with ours in about 4.5 billion years, the cosmic crash will trigger a new wave of star formation, creating spectacular new stellar nurseries. This cosmic dance will light up our night sky with thousands of new stars. Thanks for joining us on this cosmic journey through stellar nurseries. We've only scratched the surface of these amazing star factories. If you enjoyed learning about space, hit that like button and subscribe for more stellar content.